Hello everybody, I am Chris, also known as the Cryptic Chameleon. Welcome to the stream for those that are watching live. I appreciate you being here. It has been an interesting time, and happy holidays to everybody. So Merry Christmas if you celebrate Christmas, Happy Hanukkah for those that celebrated Hanukkah, Kwanzaa, and happy whatever secular holiday for those who don't believe anything. That being said, and a happy new year to everybody as we're approaching the new year. So new years mean new things, and I recently migrated the crypticchameleon.com website over to a new web host, and I also, in the process, updated the collectivecast.com website and the way that that podcast is handled. So some pretty cool things there. Today we are going to be, okay, so this is on this side. Maybe I should turn the camera more. There we go. That's better. Okay, there we go. Left hand, right hand. Okay, that's a little better. Ooh. Whoa. Why'd I get a Epic Games pop-up? Yeah, sure. Okay, so this is an interesting game. It is... Whoop, wrong thing. This is a game about AI, and I wanted to play this game so I could learn a little bit about this, because I've never actually done it. I know a little bit about AI, but I've never actually done a ton with it. So I figured this would be a good opportunity. I guess we're going to start with the tutorial, which makes sense. To become a programmer, you must master your art of turning the computer on. Press and hold the flashing triangle. When done, press the power button that will appear in the upper right-hand corner of the screen. Oh. Okay. I see. All right. I got it. Okay. Oh, this is cute. No, not an error. Put the coffee down. Ah. Make more coffee. The cat is sitting there. The cat is programming. Wait, what's going on? Build successful. I have no idea what I'm doing. Programmer returns. Cat's looking all smug like, hey, I had a clue. Meow. Hey, what did you do? Did you do that? Holy zeros. If I could only understand what this cat was trying to say. Meow. I guess we'll have to find a way to find out a way to recognize your speech. Meow. Goal: cat speech recognition. To-do list. Google it on Cat Overflow. Continue. Enter my nickname. Okay. Okay. How to recognize animal speech. Recognizing animal speech. Hey everyone, can you believe my cat? The little devil has debugged my code. Again! He definitely has something to say, so I decided to make some sort of system, algorithm, which would help me understand him? Give me advice. Wish me luck, maybe? Yes, I'm not insane. My mom had me test it. Aww. You had to take something from Big Bang Theory, really? Okay, F5. Don't rush ahead of your... No. Making a device that would be able to detect the cat would be a nice start. You can work with video, sounds, etc. when the time is right. Hey, a couple of days ago, I've been reading about how expert system can be applied for detecting animals and writing chatbots. The newspaper was called Deep News. I'll be sending you my copies once I'm done with them. Okay. Welcome to your workspace. This is where programming magic and bugs, mostly bugs, is born. To begin, drag an expert system node from the list on the right. Okay, so we're dragging this expert system node. Drag the connection line from the starting node on the left to the expert system node on the right. If you want to delete connections, place your mouse over the line and press the right mouse button. Okay. Okay. So we have, input from camera. Okay, so we have an input from a camera. And we have an expert system that is supposed to tell the difference between two different photos. So photos that are red are photos with a cat. And photos that are blue are photos with no cat. Let's go ahead and test it. All right, the red ones are going to the red, and the blue ones are going to the blue, so that's working. That's good. So we're going to let this simulation run for a while until it's fully built everything up. I could make it go faster, but I guess this is sort of how AI actually works. All right, time spent 21 out of 26, nodes used 1. Continue. Okay. Hey again, I've tried the expert system and it hardly makes any sense. Squares are floating from left to right. Is that what the fuss is all about, machine learning? Are you guys actually working there? This is called visual programming, my fellow dude. Yes, this is how it's supposed to work. The expert system analyzes your data input from the camera and checks if there's a cat on them. No, it's not what machine learning is all about. It will get hardcore soon enough. Well, I'm not good at it yet, apparently. When do I actually start building a cat translator? Don't rush it, friend. You gotta master your machine learning ninja skills first. I'm working as a freelancer and the amount of contracts is crazy. I'll forward you some jobs I don't have time for. It will help you to get on your feet and earn some cat bucks as well. Check your mail now. P.S. You're still paying for the servers, though. Hey, Cryptic Chameleon at cat.meow. Noob advice. There's an auto help for each new technology. Very convenient. I've turned it on for you now. No need to thank me. But you probably want to change your password. My cat talks 123 is pretty obvious. Okay. Behold the task tree. This is the map of your progression in the game. Vertical progression stands for story quests. Horizontal progressions are optionals. Icon colors stand for different types of machine learning tasks used in respective tasks. Sounds pretty simple, or so we hope. Alright. Applicants. Good day. We're from a public school. Summer exams has ended, and the results are attached to the letter. Could you process them and predict which of the students will be able to enter MIT? Okay. See these colorful geometric shapes? They represent various kinds of data, numbers, letters, elements of images, etc. In the modern world, everything can be turned into data, and machine learning is all about sorting and interpreting that data. Okay. Long story short, your goal in the game is to transfer data from the left part of the screen to the right. These bars show the minimum amount of data that needs to be processed to complete the task. Okay, so I have exam results here. And so we have two output streams. Well, hang on. I've got to put in my expert system here. And we're going to change this to green. So this goes here. If it's green, put it in the green box. If it is blue, put it in the blue box. And let's do a test run. Okay. It's working. Hey, Dempsey. How's it going? It's good to have you here. I'm learning about AI. Release the program to complete the task. Hooray! First bit. I will accept. Errors in DB. Okay, so, task tree. Going good. You got a new phone and a new project. Congratulations on that. That's cool. We have some errors in our questionnaire data. We can't solve the problem by ourselves. Can you please fix it? Sure. Your efficiency is measured not just money, but with models too, or medals too. Medals influence your story progression while boosting your self-esteem at the same time. To get a medal, your scheme has to meet the respective time and node limits. You can improve your results later on. In the game, this node destroys elements. Important detail, no matter how many trash cans you place, they will count for one node in the node's limit. Real data sets have lots of errors. Filtering out errors is a very important skill for all data scientists. So let's read this article here, seeing as this is... Oh, you've played this game. That's cool. Ultimate Guide to Data Cleaning. So let's see. Spent a couple months analyzing data from sensor surveys. No matter how many charts I created, the results are always misleading. Throwing random forest at the data is the same as injecting it with a virus. A virus that has no intention other than hurting your insights if your data is spewing garbage. Even worse, when you show new findings to the CEO, and oops, guess what? He or she found a flaw, something that doesn't smell right. Your discoveries don't match their understanding about the domain. After all, they are domain experts who know better than you as an analyst or a developer. Alright, so let's see. Incorrect to inconsistent data leads to false conclusions. How well you clean the data has a high impact on the quality of the results. Garbage in, garbage out. So quality data beats fancy algorithms. So a simple algorithm can outweigh a complex one just because it was given high quality data. Wow. Foreign key constraints. Foreign key column cannot have an enter or a value that does not exist in the reference primary key. Mandatory constraints. Certain columns cannot be empty. Unique constraints. Field or combination of fields must be unique across the dataset. So that's interesting. Data type constraints. Cross-field validation. Certain conditions that span across multiple fields must hold. For example, patient's date of discharge from the hospital cannot be earlier than the date of admission. Interesting. Alright, this is way too long to cover here, so let's get back into the game. Okay. So, faulty data. I think I know how to do this. So I'm going to have to create 3 nodes in this case. Red, green, let's see. Oh no, I can only have one of these. Oh, I think I know how to do this. Okay. So we'll look for red first. And if it's not red, it's green. And I will have a trash can. Okay. So red's going to go to the ending. And green's going to go to the ending. And anything else is going to go to the trash can. So, my nodes limit is 3 instead of 2. But I want to get red and green over there. Well, I could do it a different way. No, that doesn't make sense, because they want red or green. That's tricky. So, this is an if-else statement here. I'm only allowed 2 nodes. Alright. So here's my first node. It allows me to detect red. And if it's anything else... Oh, I got it. I figured it out. We'll just reverse it. I was overthinking it. Nope. So if it's blue, I'm going to send it to the trash can. And if it's red or green, I'm going to send it to the output. I think that makes sense. See, I was overcomplicating things. I was looking at like more than one way of sorting it. All right, let's see. That works. Hooray! Okay, errors in database number 2. Let's take a look at this. Found some new types of errors. Please update your program. It'll be easier if you use the previous version of the code. Okay, so I will. Mankind has always been trying to create artificial intelligence. Before the invention of neural networks, people used expert systems. An expert system is a deterministic algorithm which reproduces the decisions of a real person. An example of this is Eliza, the very first chatbot in the world. It was created in 1966 and talked with patients using questions similar to a real psychotherapist. It worked horribly. Custom nodes are special nodes containing previously designed schemes. Press the middle tab to switch to the custom nodes list. Drag the custom code, sorting the color red to the workplace. If you want to modify the scheme inside each custom node, double-click on it or press the down arrow icon in it. Okay. I mean, or you could just build it yourself, but that's fine. Okay. There we go. Hooray! Aw, that's cool that you have the little notes. This is a fun little game. How to recognize a cat in the picture? Ah! There is no way to detect the cat without using expert system. It works for text, but with pictures, not so much. Furthermore, the cat won't sit still. That it does not. Try decision trees then. Those are like expert systems, but on steroids. Once you feel comfortable around them, try SIFT. This little devil is way more effective with pictures. Also works nicely when paired with other algorithms. Or you can use nails or glue. Come on, it's just a cat. It won't fight you back. Okay. Different nodes have different processing rates. This will influence the efficiency of your schemes. Icon on the right indicate the amount of time required on each node to process one data element of data. In the game, the node compares output parameters, the sockets, with an element's color. If an element's color is equal to only one color socket, the element moves to that socket. If an element's color satisfies both conditions or none of them, it chooses a random socket. In the real world, decision tree is one of the basic machine learning algorithms. Each tree knows a limited amount of classes. For each element, the tree asks some questions and chooses the class most similar to the element. Okay. So the decision tree takes a shorter period of time. But you can only have one element. Oh, I see why this works, because the green can go to either anyway, so it doesn't matter. So the red, so basically it will choose a random node to assign the green to if you have a decision tree. So if it's red, it's going to go to red. And if it's blue, it's going to go to blue. And if it's not red or blue, it's going to be green. So it will go to one of these. All right, I will test it. There we go. Awesome. Ooh, we have a few different systems here. That's cool. Good day. I study ancient manuscripts and books in order to figure out the true story behind the Illuminati secret society. Right. I need to recognize all the triangular shapes in these documents to solve the puzzle. You design a program that'll do that for me. Okay. To decrease and increase speed. Yep. Got it. In the game, this node compares shapes. If an element's shape matches the designated shape, said element goes to the top socket. Others go to the bottom socket. So if it matches, matched items go to the top and other ones go to the bottom. SIFT, Scale Invariant Feature Transform, is one of the most powerful non-neural algorithms for detecting features on pictures, which is essential for image recognition. SIFT is very fast and is capable of recognizing simple objects and patterns. Okay, cool. Alright. So in this case, they only want the triangles. Alright. Let's test run it. Only triangle. Let's see. Oh, stop. Duh, I have to connect the data. There we go. Think we got it. Sweet. And maybe I will move this back over this way. There we go. Hooray! Working for the man feels too easy, boring, or soul-sucking? Aim for the sky and become a CTO of a startup. In the world of savage market laws, it's either sink or swim. Will you get rich or bite the dust? It's worth trying anyway. So, I mean, I'm going to do all of these side things. Hi there, my name is Sarah. I own a small technology farm. Our distributors demand supplies of eggs of different kinds, and it takes a lot of time to sort them manually. That's why we decided to automate the process. We have all the data about egg parameters, but we need an algorithm which will work without human assistance and with high accuracy. Okay. I can only have 2 here. Only triangle. Oh, okay. So I use my only triangle algorithm. And the triangles will go... No, but that'll discard everything else. I don't want to discard everything else. I remember it saying something that you can modify it, but I don't remember how. That's not good. So I have to figure out a way. So I have an algorithm already that'll sort out only triangles, but that only gives me one other option. wonder, how do I modify this? There we go. There we go. Okay. So I've updated this. Okay, hang on. I'm not done modifying that. Darn it. I thought that would be it. Oh, there's no output stream. So with this, the only output stream is triangles. Well, I know I can sort the triangles. Like, that's easy enough. I have an idea. No, that won't work either. Because I'm only allowed 2 nodes. And my ideal would be... I mean, can you have multiple connections? So here's what I'll try. No, that won't work. Let me think. So one gets just the triangles out. That's all this does is sorts triangles. But that still doesn't get the level of accuracy between the others. And I can only have 2 nodes. And this would only be able to sort between... But the problem is that then this would include triangles. I don't know. I'm overthinking this, I bet. This is a little bit trickier just because I have to be able to sort 3 things. I have an algorithm that will sort one of them, but I have no way of sorting between... And then I won't get accurate results here. Others go to the bottom socket. I just don't know. Because this will output to here. That much I know. But that doesn't solve the problem of... not having an additional output. Gotta fix this again. So again, the output from that is going to be there, but that doesn't eliminate or allow me to sift between the two things that I need to. See, that's not going to work. See, I could sift just the triangle. You know, I'm not going to use this only triangle one. Like they said to reuse it. I have a better idea. All right. So if it's a triangle, go to triangle. Otherwise, go here. Let's see. I mean, it's slow, but it works. Hooray! Vortex, welcome. Welcome on in. Thanks for being here. My name's Cryptic Chameleon. What's going on? I am learning about AI. Oh, Dungeons. Oh, okay. Sorry, Dungeons. You switching up your name? Ah, that's cool. How are you enjoying the what do you call it? The tower release, so to speak? Our company is manufacturing all organic painkillers used to go suffering mood improvement. Okay. So known side effects are caused by the human factor. From time to time our workers pick the wrong plants. Right. Okay, so we're going to do a color sort here. How many nodes can I have? 3. Nice, you bought the battle pass. Congrats. Okay, hang on. So, expert systems will sort out one thing. See, decision trees are different though. So like, here's a decision tree for red or blue. So I could put red there, and I could put blue here. And then expert systems. See, green can go to all though. So I could use 3 expert systems. Let's see here. By the way, Vortex, I updated the Collective Cast website. Now it uses federated social networks, and it also has a bunch of other features. It's pretty cool. If you get a chance to check it out. So this one only sorts out one color. I've got it. Let me disconnect all these. I've got an idea. So we already know that blue can only go to one place. So blue can go here. Trying to think what's more effective. Oh, wait, no, there's another way I could do this. Hang on. So let's say, what we'll do is this. Oh, you can only, I see, okay. So green can go to any. I wish you could have a single output from, hey, it's 2 a.m. hacks. Nice to see you. Man, this is harder than it seems. Okay. Oh, wait, that's right. I have algorithms I could do. Green, blue, divide. Without blue, only red. Red, blue, tree, divide. Green, blue, divide. All right, so hang on. Green, blue, divide. What is it? It said it's red else divide, it says. Hang on. No. I want... Alright, green, blue, divide. Red else divide. No, because I can send red or green to either one of these. This is tricky. See, red can go to 2 different places. Red's allowed to go to 2 different places. See, an expert system... The one we have to immediately sort out is blue, because blue only goes here. Red and green can go to either of these 2 places, and it doesn't matter. I just wish you could have multiple outputs. Yeah, it's good to see you, Hacks. I hope that you're having a good time. I'm trying to figure out the best way to approach this. So, red-blue tree divide. Only red, without blue. Green-blue divide. Red else divide. Extract blue, then consider red and green afterwards. Yeah, I was thinking that. Like, without blue. So, like, if I wanted to, I would say, make this blue. But here's the thing, this can accept green too. So then how do you split green across 3 different ways? Yeah, I know. It's interesting, right? So this would extract the blue and send the blue directly here. And then we have green and red, but green and red could have 2 outputs. So, like, regardless, this would be successful. And I could actually just maybe do the same thing. This is less efficient, though. But then, the problem is that... Divide to both 0 and 4. Well, the other problem is this should accept green as well. So technically, green can go to all of these, which is where we run into a problem. So it makes sense to sort out all the blue first, but then how do you distribute things equally amongst these? Well, I thought of a weird way to do it. No, because then you still have the delivery of green. Hang on, green is the most common of all of these. Green can go to any of these. And I can have up to 3 nodes. So I can find items that are not blue. Or, whoops. No, I want without blue. Okay, hang on. Oh! Okay, I've got it, I've got it. One. Oh, man, you can only have... Why can you only have one connect... So you can only connect your data to one initial point. That's dumb. Wait. I've got it. Okay. Let's see. Can this connect to multiple things? No, it can't. That would get me connected to here, but then I don't have anything to connect this to. See? That doesn't work. I have to have 3 nodes. Because I have to have 3 outputs. Blue else, direct the blue one to 2, and direct the else to divider 1 to... See, this is the tricky thing about programming. It's never as easy as it seems. Yeah, it is a hard game, but it's like... Okay, so hang on. We want to be able to get green and blue here. Only red. Red, blue, tree, divide. Only red. That deletes other things. Without blue. Green and blue divide. Red else divide. I don't want to delete the rest of the data. This is trickier than it seems. Let's see. See, no matter what I do, I'm not going to satisfy the green here. Because here's the thing. I could do... Yeah, but then I can't connect that to something else. So that still doesn't work. So actually, the most common is green. This is bloody tricky. I can divide between red and blue. First one needs to be blue else. Yeah, but that only gives us one output. So like, yeah, I could do blue else here. But then I still need to somehow get green here as well. So now, if I'm only sending blue there, that eliminates blue from the rest of the data streams. How was my Christmas? It was pretty good. Pretty good overall. I appreciate that. Okay. See, then I'm just dividing between red and green, but the problem is that, so like I could easily do this, but that only handles one node, and it doesn't account for green being in this node. You can only use 3 divisors. So I can only have 3 nodes. So let me think here. This one takes out... Oh no, any... Yeah, so red versus any. Okay, so hang on. Blue versus any. So blue is going to go here. I will then set any. I'm just going to see what happens here. I don't think this is going to run. I ran out of time. Oh, nodes used 2 of 40. Wait, it says I could do 40 nodes? Wait, how? But it was only showing 3. How does... That's a bug, right? That was a bug. You can't have 40 nodes. Like, you can only have 3. So you can only have 3 nodes. But it's not accurate enough because I'm not getting the red... The blue and green here. The other option is... we start by taking out the red. No, that's not going to work either. Because I could technically take out the red and then do this, but that doesn't support output stream 4. Where's output stream 3, by the way? So you got 0, 2, and 4. So we can use a total of 3 decisions, basically. So we can have, essentially, we can have some existing decisions, which are, we can make something without blue, which would be green or red. We could have something divide between green and blue. is there a pure splitter without categorizing output? Let's see. Oh, here we go. Any and any. That's a good idea. So this is basically just to divide the data. I like where you're going. Okay. Now. Question is what to do now. You divide green and blue. Okay, so here's what I'm going to do. I'm going to have one output divide green and blue. And the green's going to go here. And the blue's going to go here. And then... hang on. I can only have 3 nodes, though. Just trying to think. You know what? I'm going to intentionally change this. I'm going to do red. Oh, no, I can't. Because that has to go to green. And this has to go to blue. Okay, so that doesn't work because this has to start with divided. All right, so this is a pure decision tree saying to split out any equally. But you see, no matter what, I'm not going to get any results to... I could do a red... Hang on. No, I don't want only red. I want... So we have a red-blue tree divide. So that solves one condition. Then we need a... red, green... Green would go up here. Nope, that still doesn't solve the problem. Okay, wait. I know what to do here. Hang on. This can go. Alright. So we're going to do red else. So this is going to get one set of data. Got red. Anything else goes here. That solves for part 1. And the reason that solves for part 1 is because if it's not red, then it's going to be blue or green. Okay? Alright, so we got that done. The next thing we have to do... So we have red going here already. The only thing that we won't have is 2 output values to here, though. Unless we have a blue else divide. Alright, hang on. Still doesn't work. Anyone connected to without blue, without red. I don't know. Are there any hints in this game system? I mean, I'm sure there's solutions out there. I'm just trying to wrap my head around this. So we have 40 green to sort, and the green can go either here, here, or here. I wish you could connect more than one output to more than one thing, but you can't. Let's see. That could be handled by blue else. That could be handled by blue else. But that still leaves this, and you only have one connector here, which means you can only connect out to one node. I could have a total of 3 nodes. So, like, for example, I could say only red goes here. I can do a green-blue divide here. Blue and green. Okay, hand. I don't think we need an any. We just have to find a way to divide these out equally here. Somehow we have to have output to all 3. These only need blue and green. These need red and green. Options are to red else, which would put us here. Like, red will give us... So that immediately takes care of blue and green. The problem is then we don't have any way of getting green and red. Without blue. No, not okay. Anything without blue would solve this. Then we would still need a way to get green up in here with only 2 connections. I don't know. I guess I'm gonna have to go back and try that one again another time. Back to my tree. Okay, so that's a bonus one anyway. But the point is that I would like to get that done so I could take care of this task over here. Let's take a look at optimization. We changed our database system. Can you update your code one last time? We need it to work faster. Oh, that's easy. And see if this works. Wait, no, that won't work. Well, it will work. Let's see if it's fast enough. Oh, duh. Data in. There we go. That worked. What in the world? How'd I run out of time? Nodes use 2 out of 30. How does it say 2 out of 30? And how did that not run? Let me just test run this again. Money spent. Nodes used 2 out of 30. Occupancy 5 out of 8. How? That doesn't even make sense. Oh, I only got 5 result. Wait. There's 10 here. Hey, McMonkey, good to see you. There's 10 here. There's 10 here. So, let me test run. 1, 2. Oh, that's why. Nope. Stop. Okay. I see what's happening there, so I can't do that. Oh, there we go. There. Wait, it's supposed to be only red that gets over there, so why is it still doing... Oh, that says without blue. No, that's not what I wanted. I wanted only red. Oh my goodness. How's it going, McMonkey? What have you been up to, though? How have your holidays been? And everything. I got a really cool book, actually. If I have enough time, I'll fetch it in a minute. I don't know if this is going to do it in fast enough here. Nope, not fast enough. I mean, I could try this. But I don't think it's fast enough. They want efficiency. See if that's efficient enough. Nope. Okay. Oh, I got it. Hang on. Yep. Here we go. Because this, it's okay for this to be a little slower. Oh, your winter job. Nice. You're 1 affiliate away from, or 5 away from affiliate, and your baby boy is happy. That's great. All right, let's try this. And, oh, so close. It's still too slow. Trying to do this as efficiently as possible. See, this is a red else divide. But it only gets rid of blue. Okay, hang on. That only accounts for... Hang on. There's a red else divide. There's a green and blue split. There's only red, but that takes too long. Let me just try something here. I just want to see what happens if I do this. Let's see what happens here. So it's still going to send the greens over. But it's not accurate enough. Okay, I got it. We're going to do red-blue, and then we're going to do red-green. Oh, that's not going to work. Oh, no. Trash can only counts as one object. Ha! I think we got it here. Let's see. Yeah! Managed to get it done. All right, hang on. I'm going to step away for like 2 seconds. I want to show you this book that I got. Give me a second. Okay. Oh no, it's not going to show it. Well, it's called the X-Files, the official archives. And it actually looks like it has real case files from the X-Files in there. It's pretty awesome. I love this book. I was watching an episode from season 7 last night. And when I did, it allowed me to, like, I was able to look up the case file in this fake case files book. So that's pretty cool. Hooray! All right, so we got that one done. MedX is the one that we're still working on. So the thing is, we need 3 output streams. Now let's think about what we did in the last example. Oh, that's not what I want. No. So we have a red-blue tree. All right, hang on. I've got it. All right, I think I figured it out. We're going to do... So again, if I did come out with a new episode of the Collective Cast, by the way. So I'm going to split this data. Actually, this might work. No, I don't want only red. All right, let's see what happens. I don't think it's fast enough, is it? Yeah, it is. Woo! We did it. Look at this. Oh, yeah. That's exactly what we needed. Yeah. Maybe it wasn't the most sophisticated way to do things, but we did pretty well. Woo! Wrong button. So like I was saying, I did redo the podcast website. If you go to collectivecast.com, and I came out with a new episode on December 24th. Wait, I didn't want to escape. Hang on. I'll go back to it in a second. I just want to show you the new website while we're working here. So this is the updated Collective Cast website. You can see all the different crazy places you can listen on. You have all the different episodes. And if you are on any kind of... You can get into each individual episode by clicking on the episode title. And if you want to leave feedback, the way to do that is to be part of any federated, social network. So you can follow Collective Cast at www.collectivecast.com. And what that will do is that will then show up on any federated platform, meaning Mastodon or Friendica or any of those platforms, and will allow you to comment on the episodes. So it's pretty cool. Anyway, let's get back to the game. Hey, I pet the cat. That's cool. All right, let's go to Pizza Shack. We're honored to invite you to join our startup, the world's first AI-controlled pizza place. But our fingers are always stained with flour, and we can't really code because of that. Help us write and implement an algorithm that would be capable to separate orders for round pizza from square pizza. Well, that's easy. So, they want round or square. That's easy. Round. Square. Go ahead. There we go. Okay. These are the users of your startup. Heard of amazing place and they want to grab a slice. These are your client's orders. The millennials don't care too much about topping. Only shape matters. Really? Mind the accuracy. If a client gets a pizza they've ordered, they will pay you money and tell your friends about it. If client doesn't get what they ordered, yeah, okay. Okay. Good. Cool. Nice. Time is passing by and the market changes. When the hype is yellow. Okay. When the hype is gray, you've satisfied the target audience. Users are starting to leave. Watch your earnings. When the number becomes red, it's time to cash out. Oh, they only have 2 outputs. Oh, cashing out. Sweet. There we go. That's how you make money. Cool. You have reached the end of Epoch. Join one of the banners to proceed further in the story. I will go with bronze. First chatbot. Okay, here goes nothing. Nothing much, actually. Didn't work. The cat has been detected. Continue. The dawn of civilization. All right. Rosenbot perception. So we've got a lot of different directions we can go to. Oh, here's a new one. I forgot. I unlocked it. I unlocked this one. Okay. Research on crowd psychology. We need an algorithm which will be capable of defining a person's type based upon certain behavioral patterns. This way we'll be able to quickly identify dangerous individuals in a crowd. Okay. That is a lot of data. Wow. Mm-hmm. Oh, so this should only be circles and squares. Okay, I see. Okay, here we go. So only triangles. So triangles are going to immediately become this over here. But we only want... Oh, wait, hang on. Circle, square, triangle, shift. Shift. No. There we go. Okay. So triangles can go here. But, hang on. Only red fast. Okay, hang on. Green. No. I need... Oh, that's not color-based. No. Because I could sort it down in triangles, but then you're going to get a bunch of triangles that don't fit. Alright, hang on. Circles. Squares. No, that's not going to work. Alright, hang on. So you're saying triangle else. So only triangle. Alright, triangle else. Hang on. Okay. So we're going to do triangle else. We know the output of the triangle needs to go to a color. But the problem is that then you're still going to run into an issue where... So, triangle... We know we only want the green triangles to go here. But the problem is you're still going to get... Okay. You can't do green else. You can only do a shape and else. So, here's what I'm going to do. So, I still want this to be green. Green is going to connect here. And any red is going to go to the trash. So both of these, any blue is going to go to the trash. Any red is going to go to the trash. Okay. So we've got the green triangle piece. Now, we've got it down to circles and squares. So we only want the blue and the red. We still want to get some squares here. Red squares. Yeah, I know. I'm already at 4 of 6. So, alright, hang on. Red, green, green, blue, red, green. Wait, that's red and green. I need red and blue. That's not even an option here. No! This is tricky. So let's say. Want to sort things. This is tricky. I think this decision tree is too long. All right, hang on. I'm gonna scratch this. So let's start from scratch here. Okay, our end here is red and green. So let's see, hang on. No, that's not what I want. Hang on. So red and green is going to come to here, and then I just have to sort out so that there's no... You can't do green else. You could do green any, but you can't do green else. You have to do a shape else. So here's an idea. What I'm going to do is... red and green. And... aha! Watch this. Okay. So if it's circle, I'm going to throw it in the trash. If it's red or green, I want it to go here. So hang on, watch. I'm just going to test this one part. So I'm going to test it. Alright, see, we're only getting... oh no! Ah, the colors are wrong. That's pretty bad. Okay. So, we're saying anything but circles should go there. Yeah. Let me just say this again. Alright. So how are triangles... oh, hang on, stop. Oh, that's not what I wanted to do. That's my issue here, hang on. Red, green. Okay. Now I'll test it. So this is going to be my primary decision point. Nope. Still not accurate. It's a circle, it should go in the trash. Anything else should go over here. And it should only be doing... Look at this. Red, green, red... Oh, this is my one from previously. How is that 5? Oh, it's counting all of these. 1, 2, 3. If I remove that, it brings me down to 2.
Oh, this is frustrating.
Let's see. No. Alright, let's start with the circle, square, triangle sort. Alright, hang on. Know that triangles can only go here, and even then it's only green. So... Wait a minute, square will work though. Watch this. So, square... can go here. But it could also go that. Ah, this is complicated. Darn it. Let me think. Red, blue would also include green. Only triangle makes it so that there's only triangles. Only red, fast, isolates all the red stuff. But it discards everything else. It's complicated. So the thing is, there's also green here. So if I sort between red and blue, it's definitely going to get red and blue here, but it's also going to have green. Can I tie more than one of these to a single node? Yes, okay. Then what's the point of that? Never mind. Okay. So because this is divided between red and blue, it's automatically still including green. So right now, all of the circles and squares are coming here. Let me try something. Oh. Green, blue, red, green. Okay, and triangle's gonna come in here. No, I don't want red or green. So, I only want squares and triangles here. That would be... Nope. Not gonna work either. Let's see. See, the thing is, squares could go in multiple directions. Squares. This is gonna be weird. Okay, so I'm gonna take squares. And I have a choice of green or blue. But not any red. I want blue squares to come up here. And blue squares will also contain red squares. But green squares will also have red squares. So then what I could do is this. And the blue can go to a trash. Still too complicated. Darn it. Because that's one decision tree. So that will get green and blue, or red and blue squares here. But that doesn't...
Solve my problems.
Wait a minute. If I take triangles... And triangle. Green triangles will go here. Oh no, then it's not sorted by... Oh boy. Okay, let's tear it apart again. This is what programming's like in real life from what I heard, or from what I know. Okay, so let's start triangle only. Triangle else. Alright, so I'm trying your way, hacks. I'm gonna do triangle else. The second one is gonna be a red green shift. Okay. So red, green. 3 is also red, green? Okay, so hang on. Triangle to 3, which is red, green. Okay. And the else goes to 2, which is also red, green. Okay. Triangle to 3, else to 2. Alright. So this is the triangle to 3. 3, red to trash, green to output 1. Why would green go to output 1? You mean output 3? Green would go to output 3. And yeah, but then that's still going to include blue. You see, like, this is so complicated. Okay. All right. So that's not going to work as I'm looking at it. Yes, it pushes blue in the red gate, but it also pushes blue through the green gate. That's the tricky part. So hang on. I want to look at the one that gives me 3 splits. Yes, because if it's not including the color, it will. All right, so hang on. Now that's circles. No, that's not the one I want. I want the color splits. Okay. Stop. All right, color split. So we've got red and green, we've got green and blue, and we got red and green. Okay. So that's okay. Okay. So the first one is going to be red and green. So here's what I'm going to do. This is red and green. So what I'm going to do is I want it to be circle, a red and green circle. The circles will go up here because they're going to be red. And we want green. We want green and red. Oh, hang on. Red and green. So we want the circles to go to the trash, I think. No, if it's red, I want it to go up here. Green can go to the trash. Nope, that's still too complicated. I just want to test to see if that much worked. Let's see. Nope. My logic... Well, actually, my logic worked. The problem is that I didn't get the input I needed here. Okay, so I can't sort by color first because that's too limiting. Hang on. Hang on. Split this by red and blue. Start simple. If it's red and it's not a triangle, that doesn't account for green. Look at my larger decisions here. So we got red and blue. No. See, circles in the end still need to... See, that counts as 2 right there. Oh, that's only triangle. Hang on. Alright, so that counts as 2. Well, let's think of this logically. The only place that circles has to go is up here. And the only colors we need are red and blue. So that means we got to get rid of green. There's no easy way to get rid of green. Well, that's what I'm trying to do. So, like, for example, circles only get here. There is no green any. That's the issue. This will sort red-green, but then that uses up 3 different decision trees. And that doesn't help me. See, circles are only needed up here, and triangles are only needed down here. That much I know. But then I've got to figure out how to sort by color. Alright, hang on. So this is going to include green, half in red and half in blue. Now, no, that's not going to work either. Dang it. Damn it. Doesn't make sense. Alright. You notice how many reds we have too? And how many green triangles there are? Red and green. Green and blue. Okay, so hang on. Red and green. That's 3 there, though. Nope, that'll use us up too quickly. Because this counts for 3. Yeah, that's not going to be a good decision point. I could switch. Like, I could split between triangles, squares, and circle, square, and triangle. But the thing is that the squares have to have the potential of going to 2 places. So unless squares, what I do is I say, okay, no, that's not going to work. hang on. Okay, I've got an idea. So, any shape that's triangle has to go down this way. Okay, that's fine. Any other shapes can go in one of two directions. Now, what we don't want is circles down here. So, and we don't want anything but green and red down here. What I'm going to do is, I'm going to say, okay. Okay, so this is where we're going to deal with the... Because technically the reds need to be able to go wherever. Because technically... Yeah, green triangles is still going to take 2 operators. Actually, it would take 3. Because if there's only 2 colors, the third color, and you're sorting 3 colors, the third color gets split equally amongst the other 2 colors. This hurts. My brain hurts. Let me think. I'm gonna have to wrap this up soon. Holy cow. Been on here for a while. Dang. Okay, hang on. Let's look at the different operators we have here. See, we have a red and blue tree divide, but then that's also going to include green. That doesn't help us. We have a red-green, a green-blue, and a red-green. Now, if we pull this out here, it counts as 3, because it has 3 outputs. So, red-green, if you could find a way of... Oh, hang on. Hang on. Wait, that's only... Alright, hang on. And the green would go to the trash. Now... let's see. We got that sifted down to circle. Sending red and green squares here, but sending red circles up here. Nope, that won't work either. Yeah, I know. Maybe. Well, we gotta wrap things up anyway, so I'm gonna go ahead and mess with this a little bit later on. Where you can buy with eBay. Oh, I see. Oh, you could buy little, like, plants for your thing. Oh, you could buy more nodes. Oh, cool. That's cool. Make things faster. What cat do I want? We'll stick with the Cheshire Cat. Oh, never mind. No. Okay. So we played around enough with this game today. I think we're going to wrap things up. Let me just look at my inbox really quick. Oh, private. A letter from mom and dad. Oh, they give me free money. I'll take it. Hovland and Hunt. Huh, interesting. Nice. We'll see, Hacks. I mean, maybe. Depends on what we're doing. I think I don't have a ton going on the 30th, so it may very well be a possibility. In the meantime, let's go ahead and exit this. That was fun. Wait, I'm going to save. Oh, I almost didn't save my game. That wouldn't have been good. Okay. So let's go ahead and exit. And, no, I want to actually... Thank you. Okay. So, I want to thank everybody for watching. Thank you to both Hacks and to Hacks, McMonkey, and also to Vortex for joining today. Again, if you do want to check out the podcast, the place to do that is collectivecast.com. You could definitely check that out. There's quite a bit of stuff there with links to all the different places, and definitely check out different Mastodon federated social networks, because then you can follow the Collective Cast on there and get notified whenever new episodes come out, and you'll also be able to comment on those episodes, so that's pretty cool. Other than that, not a ton going on. I hope that you all have a great rest of the kind of down week in between holidays. And until next time, take care. See ya.